So here's problem number 2 of our optical rotation. All right, so this one's going to be working a little bit differently from the last one. So we're going to work backwards here because I was actually given the percent composition of our mixture, but we want to know what the optical rotation would be of that mixture. So we're told that our positive enantiomer here is equal to 25 degrees. If I know the positive enantiomer is positive 25, I can go ahead and make that assumption that the negative enantiomer would be minus 25. I don't know if that's useful yet, but I'm just going to jot it down in case I would need it. So I'm told that a sample has 80% of the positive enantiomer, and I have 20% of the minus enantiomer. And what's the optical rotation? All right, so if I'm looking at these, I know I'm going to need my percent EE equation because what that's going to tell me is I'm going to have the specific rotation of the mixture, which is what the problem is asking me for. And then we always divide by the specific rotation of the pure enantiomer, which would be the reference number, which I was given. I actually know for both enantiomers what that would be. And then I'm always going to multiply this by 100% to get my percentage. All right, so I'm going to need this equation. All right, so I got to work backwards. So I was given my composition, and I should be able to use what we did before to determine this. So I'm going to walk through the path we normally go is, which we would calculate the percent excess that we have. Once we find that percent excess, we usually take that value and subtract it from 100%. And that usually tells us what percentage is racemic. All right, so we did that in video 1. And then we would take that percent racemic and we would normally divide that by 2. And that would tell us the percentage of our minor components of the mixture. And we would determine the percentage of the major by adding the percent EE. Oh, okay, let me finish the percent sign. We would add the percent EE to that percentage of the racemic divided by 2, or let's go ahead and say the percent of the racemic after we divide by 2. Okay, so I want to do this backwards. I already know that my major is the positive enantiomer because there's more of it. So that means that the minor is going to be the negative enantiomer, which is just the 20% here. All right. I know that the percent of my major is 80% because that's what I was told. I need to figure out what percent EE is going to be. And I did that by adding 20% here. So therefore, it must be that my percent EE was originally 60%. So I can use this to plug back into my EE equation. So 60% is equal to the specific rotation of my mixture, which is what I'm interested in finding. So I'm just going to write that as X, divided by the specific rotation of the pure enantiomer. Well, if the major is the positive, that means my pure value is the 25 degrees, and then I would multiply by 100%. So now all I have to do is solve for X. So here, X should be equal to, so the first thing I would do is divide both sides by 100. So 60 divided by 100, and then I would multiply by 25. So I'm getting that I should have an optical rotation of positive 25. That should be the value of the mixture to get this composition, but we can check that. So if we had time, what we could do is really fast use this and work and go the normal way of working forward. So let's pretend that this was our mixture optical rotation. So like I said, the first thing we find is that percent EE. So we're going to plug in that value we just determined. So our pure would still be that 25 times 100%. So our percent EE here is going to be 15 divided by 25. That's just 3 over 5, which should be 60. All right, 15 divided by 25, and then times 100 is our 60%, so that matches up so far. We would normally take that 60% and say this is how much of the excess we have. So to find how much that I'm being canceled out, I'm going to subtract that 60% by 100. I get the 40%. Now this would be the amount that is racemic. So to determine the amount of the canceled of each enantiomer, I would have to divide that by 2, and I get 20%. This should be the amount of minus, which does match up with what I had. And then I would take that amount of 20% and add it back to our 60. So I would have my positive would be 20% plus 60, and that does give me 80%, which is what I was originally given. So this should be the value of our optical rotation of the mixture.